Today we're going to take a look at the soda geyser experiment. This experiment is a classic. 1 to 2 milliliters of a carbonated beverage such as Coke or Sprite, plus a handful of Mentos, leads to a fascinating fountain that is roughly anywhere from 3 to 5 feet. But is there more to this household name of an experiment than what meets the eye? Let's dive into the science behind the Coke and Mentos geyser. Massive misconception that the public has is that the experiment is the product of a complex chemical reaction. This is far from the truth. In reality, the geyser is a result of a physical reaction rather than a chemical one. Carbonated drinks get their fizz from dissolved carbon dioxide. This is pumped into bottles at a high pressure to assure that it will dissolve. Upon opening the bottle, you release this pressure. Since carbon dioxide gets less and less soluble as the pressure decreases, the CO2 leaves the drink slowly in the form of small bubbles. When Mentos are added, they essentially speed up the process of bubble making. This is because Mentos are covered with thousands of tiny little craters at the microscopic level. These are referred to as nucleation sites. They provide a surface for the carbon dioxide bubbles to form on, which enables them to form at a more rapid rate. For clarity, nucleation is the process by which substances self-organize, which leads to a new thermodynamic phase or self-assembled structure. In this case, our Mentos are solutes creating a solution with a carbonated beverage that acts as the solvent, and the pits and divots in each Mento serve as points at which the bonds between carbon dioxide and water can break more easily. On to the experiment. My core research question was, how does the kind of carbonated beverage affect fountain height? Within my research question, my independent variable was the kind of beverage, my dependent variable was fountain height, and I kept the volume of carbonated beverage at 1 liter, as well as the number of Mentos put in at 7. You'll see in this first trial for seltzer water that I barely got a fountain at all. If anything, I'd say that the fountain was approximately 1.5 inches. Here we have Diet Coke, which gave us the tallest fountain at 26.5 inches. Very prominent, and you can also see that it has like a different shape from the other fountain. And here we have the fountain for Sprite, which wasn't as tall as the Coke fountain. It was approximately 10.4 inches. As you can see from my incredibly professional lab attire, my socks and sandals, I was more than ready to conduct this experiment. My main follow-up question was what led to the discrepancies between Diet Coke, seltzer water, and Sprite in terms of their fountain heights, with Diet Coke being almost 30 inches, whereas seltzer water barely even yielding a fountain. I believe that Diet Coke yielded the greatest fountain over seltzer and Sprite due to it containing aspartame and potassium benzoate, which accelerated bubble production. Sprite contains 94 grams of sugar per liter, which lowers viscosity, which in turn lowers rates of bubble production. And seltzer water's almost non-existent fountain is something we can attribute to it essentially being carbonated water with no additives that can accelerate bubble production. So instead of this being an acid-base reaction or something involving pH, it turns out to be just a simple physical reaction between the nucleation sites of the Mentos and the carbonated beverage. Thank you for your time. Chemistry rules.